Next we have upper bound and lower bound theorem for real zeros of polynomial. Let's read through it. Let f of x be a polynomial of degree n which is more than or equal to 1 with real coefficients and positive leading coefficients. So these are the conditions. Suppose further that f of x is divided by x minus c. If c is positive and both the remainder and the coefficients are of the quotient are all non-negative, then c is called the upper bound of the real zeros of the function. That means all the zeros will be less than c. On the other hand, if c is negative and the coefficients of quotient and the remainder alternate in sign, with 0 being considered either positive or negative as needed, then c is called the lower bound of the real zeros for the function. Let's use it and then check how it applies. A function is given f of x is equal to 2x raised to power 5 plus x raised to power 4 plus 9x squared minus 32x plus 20. If we write it in the standard format, as you see x cube term is missing, we can write it like this. Now determine if the upper bound theorem identifies 2 as the upper bound. C is equal to 2. Let's divide the given function by x minus 2. To check your upper bound theorem, we have to divide the function by x minus c. So I'm going to write the coefficients, which are 2, 1, 0, 9, negative 32 and 20. We have to write 2 on this side. Let's do the division. 2 comes down, multiplied by 2 is 4, 5 multiplied by 5 is 10, 10 multiplied by 2 is 20, 29, 58, adding we will get 26, multiplying we get 52, adding we get 72. So this number is remainder, and if we check all the coefficient of the quotient including with the remainder are non-negative, all positive. So our upper bound theorem states that x is equal to 2 is the upper bound of your for zeros of the function. What does that mean? That means that all the zeros of the f of x would be less than or equal to 2. 2 is the maximum value of the zeros, maximum possible values of the zeros. Okay. Let's read the second part. Determine if the lower bound theorem identifies negative 2 as the lower bound of the zeros. For that also you have to consider c is equal to negative 2. So you have to divide f of x by negative 2 now. Let's do that. Coefficient of f of x are 2, 1, 0, 9, negative 32 and 20. You draw a line, write negative 2 here because c is negative 2. 2 comes down, multiply negative 4, add negative 3, multiply with negative 2 is 6, adding we get 6, multiplied with negative 2 is negative 12, adding we get negative 3, multiplying with negative 2 we get 6, adding it will be negative 26, multiplying 52, and that will give you 72. That is the remainder. Now if you notice, the coefficients of the quotient here are alternating in the sign from positive to negative, including the remainder. So we can say alternating in signs. That means x is equal to negative 2 is the lower bound for zeros of f of x. That means the zeros cannot be less than -2. So we learned a lot of concepts for the zeros. Let's apply them all and find zeros of this polynomial. Let's read question number 10. Question number 10 says find the zeros and their multiplicity of this function. Now we start applying all the concepts starting from rational zero theorem. So what does rational theorem says? We find the constant term, which is a naught. It is 20 here, and we find its factors, which are plus minus 1, plus minus 2, plus minus 4, plus minus 5, plus minus 10, and plus minus 20. Then we find the leading coefficient, which is an, and it is 2. Its factors are plus minus 1 and plus minus 2. So any possible rational zero will be of the form factors of a naught divided by factor of an. Okay, any possible rational zero will have numerator from the factors of a naught and the denominator from the factors of an. So what are the possibilities? Plus minus 1 by plus minus 1, which is plus minus 1, plus minus 1 by plus minus 2, which will be this, plus minus 2 by plus minus 1, plus minus 2 by 2 would be 1, I don't have to write that, plus minus 4 by 1, or plus minus 4 by 2 will be plus minus 2, I do not need to write again, plus minus 5, plus minus 5 by plus minus 2, plus minus 10, plus minus 10 by 2 will be plus minus 5, I do not need to write it, plus minus 20. So these are the possible zeros. Let's try to type it in the calculator. When we type this graph in the calculator, it looks like this is the graph, and it looks like maybe 1 is the zero out of all these possibilities. 1 is the possible zero here. So I'm gonna try 1 to check if 1 is a zero or not. So what's my polynomial's coefficients? 2, 1, 9. So I'm gonna check x is equal to 1 is a zero or not by synthetic division. My coefficients are 2, 1, 9. We have to write 0 because of x cube is missing. 9. Then we have negative 32 and 20. So we have to write 1 here. Let's divide. 2 goes down, multiply 2, adding 3. 1 times 3 is 3, add 3, 12. That is negative 20. When you multiply, it's negative 20 here. And we get the remainder 0. So we have this remainder 0. That means one factor from here comes to be x minus 1. Now let's check the quotient. Okay, so if you notice, this 1 at 1 here is a touch point, so maybe it will be more than one multiplicity, right? Because it has to be even multiplicity because it's a touch point. So I'm gonna check 1 again, right, with the quotients. So from here I'm gonna use these quotients as the coefficients of my polynomial and write 1 here and try my division again. So 2 comes down, multiplied with 1, it's 2, add 5, multiply 8, multiply with 1, 8 here, that's 20. 1 times 20 is 20. And what do we get? 0 again. That means x minus 1 is again a factor. Okay. So x minus 1 is coming a factor, what other 0 can we try? If you look at the calculator, it looks like negative 5 by 2 is a 0, right? So let's try that. The remainder of the quotient, the reduced quotient, that is what we are going to use as the coefficients now. And we are going to try to write negative 5 by 2 here. Use the synthetic division. 2 comes down, multiply, that will be negative 5, 0. Multiply, it will be 0. So we add 8. Negative 5 by 2 times 8 would be negative 20. We add, what do we get? 0. That means x plus 5 by 2 is a factor. And the remaining quotient, the reduced quotient, will be of degree 2. So that is easy. That quotient is coming x square, 2x square plus 8. Let's find its zeros also. If you put it 0, 2x square is equal to negative 8. X square is equal to negative 4. That means x is equal to plus minus square root of negative 4, which will be plus minus 2 iota. So what are all the zeros? Let's list all the zeros. We divided by x minus 1 2 times, then we divided by negative 5 by 2, then we had 2 iota and negative 2 iota. Our degree of the polynomial was 5, so we found all the zeros, 5 zeros of the given polynomial function. And we can also actually, it's not asked, but we can write x minus is factored 2 times x minus 1, x plus 5 by 2, x minus 2 iota times x plus 2 iota. This is your function. So that completes our section 3.4. Let's do the concept connections. Dash of a polynomial are the solutions or of the equation f of x equal to 0. These are called zeros. If f of x is a polynomial of degree n more than or equal to 1 with complex coefficients, then f of x has exactly n complex zeros. Number of the degree tells you the number of zeros, provided that each zero is counted by its multiplicity. The conjugate theorem states that if fx is polynomial with real coefficients and a plus b iota is a zero, then a minus b iota will also be a zero. A real number b is called a dash, bound of the real zeros, if all the zeros are less than or equal to b. So that would be upper bound. A real zero a is called lower bound of the real zeros of the function if all the zeros are more than or equal to that number. Explain why number 7 cannot be a rational zero of this polynomial. You see the constant term is 6 and the leading coefficient is 2. So only possible rational zeros can be made by numerator can be coming from the factors of 6 and denominator can be coming from the factors of 2. So 7 is not possible by rational zero theorem. If g of x is a polynomial with real coefficients and zeros of negative 4 with multiplicity 3, 6 with multiplicity 2, 1 plus iota, 2 minus 7 iota. Now if 1 plus iota is the root, then 1 minus iota will be root. If 2 minus 7 iota is the 0, then 2 plus 7 iota will also be the 0, right? Negative 4 is 0 3 times and 6 is 0 2 times. That means minimum degree of gx would be 9. Similarly, question 8, minimum degree will be 7.